So this chapter is about acid and bases. So the first thing we will need to know the definition of acid, alkalis, alkalis, whatever you read it as, and bases. So then you have to say that you have to recognize them in the type of ions they produce when they are dissolved in water. So you also need to kind of know how these two things affect the universal indicator. So we have these two things now. So the focus of acids is you must know that it is a substance that produces hydrogen ions when dissolved in water. This is a key. If this is not mentioned, you probably get nothing if they ask for a definition. So when dissolved in water, that's another thing. So in aqueous solution, they must produce H plus. So because of this H plus ions, that means every acid will contain hydrogen H plus ions. Then you have like certain examples like the list below. I have hydrochloric acid, I have nitric acid, I have sulfuric acid, and ethanoic acid. Just for the sake of knowledge, these are strong acids, these are weak acids. This is a weak acid. Then strong acids are usually mineral acids. Of course, they don't make sense right now. Mineral acids are those that you find them in your lab. Weak acids can be organic acids. Organic acids is for you is in Sec 5. You will learn it again. Then organic acids or these weak acids are commonly found in the food you consume. So for example, this ethanoic acid, right? This is actually, okay, is there anything you want to express? You have to remember the formulas for balancing equation later on. Then they might ask you to explain why these few substances are acids. So you would have to tell them that when dissolved in water, hydrochloric acid produces H plus ions and Cl minus chloride ions. But the whole point is, if they say explain why hydrochloric acid is an acid, then you have to say when dissolved in water, HCl produces H plus ions. Same goes for vinegar, same goes for nitric acid and sulfuric acid. When they ask why are these two acids, then you have to say that when dissolved in water, they produce H plus ions. So a more detailed explanation down here. So you have the hydrogen, you have the hydrogen chloride or the hydrochloric acid molecule. So when you dissolve it in water, these two will break up and become like that. They go their separate ways. Then for nitric acid, the two will become separate like that too. So the key is this. And then sulfuric acid. One sulfuric acid, this sulfuric acid on its own, when it dissolves in water, it breaks up to form two hydrogen ions and one sulfate ion. So that you must know. Then if you have ethanoic acid, it breaks in a more special, it breaks in a special manner. That means only one hydrogen gets ionized. Then the rest of the 3 hydrogen stays inside. So this does not ionize. So it becomes separate like that. So all of them will produce hydrogen ions. So then I have a question down here. So do all compounds that contain hydrogen, are all of them acids? So they are not. Some of them are not. So like things like compounds like methane, ammonia, or this, all of them contains hydrogen, but then when they do not produce hydrogen ions when they dissolve in water. In fact, let's do some recap down here or revision. Let me ask you, why does methane not dissolve in water? Okay, this is a revision question. So because it does not dissolve in water, it does not produce hydrogen ions. Ammonia, on the other hand, dissolves in water but does not produce H+. So why does methane not dissolve in water? You can write your answer, type it out, and then somewhere in the open space. Because it is a simple covalent compound or a simple covalent molecule, that's why it does not ionize in water at the simple covalent molecule. Next, so you need to know the general properties of acids. So they have sour taste. They conduct electricity in aqueous solution. Then I will ask you why down here. So you have to explain later. They are corrosive when concentrated, and they turn blue litmus paper red. And then they change indicator from universal indicator to orange or red. Then they are able to react with metals, carbonic compounds, and base or alkalis. So these are the things you need to remember. They are general properties. So in general properties, they can then branch into physical property or chemical properties. So this is only for physical. So this is physical, then these are chemical properties. So in questions, they will ask you for physical, chemical property, or some general property. If they ask for general property, always give the chemical answers, chemical properties as answers. Okay, so back to my question, why do acids conduct electricity in aqueous solution? Need help? No, I have not been to effervescence yet. I have not talked about effervescence. Why do acids conduct electricity? When they dissolve in water, they produce H+ ions. For example, HCl, hydrochloric acid, will dissolve in water to produce H plus ions and C chloride ions. So these H plus ions and chloride ions are mobile. They can move in within the solution. So and this, because they are ions, they can carry charge, so they conduct electricity. That's why acids conduct electricity. Water to form H plus ions, to form ions which are mobile, hence they can carry charge, so they conduct electricity. Hence they carry charge and conduct electricity. So what's a base? What's an alkali? Okay, it's like this. Base and alkalis are related. So they are like the exact opposite of acids. And they react with acids to form salt and water only. So bases are metal oxides and metal hydroxides. So in the table, you have some chemical names and the formulas. So iron 2 oxide, magnesium oxide, copper oxide, lithium oxide, they're all metal oxides, so they are bases. Then bases are usually insoluble, except for those made from group 1 metals and the ammonium ion. Ammonium ion is this ion. So they are a group that dissolves in water. They're soluble bases. So soluble bases, they'll form metal hydroxides called alkali, whatever you read it. So when you have sodium oxide down here, when you add water to it, then it becomes sodium hydroxide. So this is the base, and then this is the alkali. Then and they produce OH minus ions when we dissolve them in solution. So back to sodium hydroxide. So it's a base that is soluble in water. They release hydroxide ions. So like this, NaOH. In solution, they break up into two, like that. They have bitter taste and soapy feel, and they turn red litmus paper blue. Note the universal indicator color, litmus color. Then they can conduct electricity. The reason for them being able to conduct electricity is same as acids. So they react with acids to form salt and water, and these two must keep in mind. And with ammonium salts to form ammonia, salt, and water. So these are physical properties. These are chemical properties. So same goes if they one physical property, give them the ones up there. If they want chemical property, give the two below. So I'll start with the first question. It says state 6 properties of an acid.
Our taste corrosive turns blue litmus paper red. pH less than 7
Any more?
can conduct electricity. Reacts with metals, carbonate, and bases of alkali.
Okay, we're almost there. This one.
It tastes soapy feel.
Okay. Soapy feel.
pH more than 7.
Then
able to conduct electricity in aqueous state.
Some
Corrosive
more.
reacts with ammonium salts to form ammonia salt and water.
Okay. Ammonium salt. Ammonium salt reacts with ammonium. Sorry again. Ammonium salt to form ammonia, salt, and water. Right? Did I hear you correctly? Any
Yeah.
more?
No.
And so you know acids, you know bases, you know alkalis. Then we have to talk about hydrogen ion concentration and hydroxide ion concentration, and then your universal indicator and some other indicator and the pH scale. So you have a pH scale. So this pH scale is used to measure whether a solution is acidic, neutral, or alkaline. So if you look at the image, the diagram down there, it shows you a bunch of pH values. So it's from 0 to 14. And they gave you some examples of what substances are belong to which pH value. Then there are some environmental effects. Yeah, that environmental effect is not tested, it's just for your knowledge purpose only. So pH value starts from 0 to 14. 7 is neutral, just this point. Then 0 is the 0 to 6 is acidic, and then from 8 to 14 is basic or alkaline. So at pH values which is 0, so means this point, the smaller the pH value, the higher the acid concentration. That means the higher the concentration of H plus ions. Then if it's big number, the pH value is big. Yes. So the pH value is big, then you'll be here. So that means they are alkaline. Then they contain high amounts of hydroxide ions. They contain high amounts of hydroxide ions. So universal indicator also come in pH 0 to 14. It will give off different colors when it's in different pH. So the diagram here shows what color they are in at a certain pH value. So for example, from pH 0 to 4, it will be red color. Then from 5, it's the universal indicator is orange. Then 6 is yellow, then 7 is green. So and so on and so forth. You see the bluish green and blue and purple. So you can match the pH value with the color of the universal indicator. So the universal indicator kind of gives you the indication of what pH value the substance is. Need to remember. We have some other indicators that we use, which is like methyl orange, phenolphthalein, screen methyl orange, and da, 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 da. So there are a few here. So we usually often use this and this. Sometimes with phenolphthalein. The chart is like this. In acidic solution, it will be this color, and in alkaline solution, it will be this color. So the methyl orange will be red color in acid and yellow color in alkaline solution. But you notice there's this number down here, pH range at which the indicator change color. So let me draw 0, 3 to 5, 14. So what happens is it's red here. From 0 to 3 is red, and then here is some some very complicated color, not red and not yellow, it's a bit of mix. So over here from 5 onwards is yellow. So you might see that the acid range is actually very small and the alkaline range is very big. So then phenolphthalein, you also can draw the same chart, and then it will show you that the color change later beyond the pH 7. So every one of them have their own pH, the range where they change color. This. So I have question that here. They say the table below shows the colors of two indicators, methyl orange and methyl red. So this is some indicator from somewhere. Then they are used in labs to at different pH values. So then you have 4 solutions PQRS. Okay, so methyl orange will change color at pH around 4. So for pH 2 and pH 3 is orange, red color. Then 4, 5, 6 is yellow. So methyl red is 2, 4, 2, 3, 4, 5 is red, and then 6 is yellow. So you have these two solutions. Then these two solutions, the question is, in which solution will both indicators be red? P and okay. So we have to talk about your chemical properties of acids, then later alkaline ones. So, so chemical property number 1, acids will react with metals to form salt and hydrogen only. So instead of giving you the chemical equation, I give you the reactants in word form, and then you will complete this and then write the chemical formulas for me and write the chemical equation. Please write the names of the products. You can check the formula, chemical formula for sulfuric acid in the first few slides. Fill up this. This is the salt. This is the water. Fill in the names first. Then write the full equation. So this is your magnesium sulfate, then plus hydrogen gas. Is it balanced? Okay. I hope I did not type wrongly this time. Okay, so we have sodium carbonate and hydrochloric acid. So you will write down the salt, carbon dioxide, water. So salt name, please fill up. Okay, then write. I think you can type it out, it's easier. Again, I think you can type it out. You just do it this way. Let's say if you have magnesium nitrate, so you can type it out and write Mg, then bracket NO3 2. You can type it like that. I can see it. What is the formula for sodium carbonate?
Na.
Sodium is Sodium is Na plus. Carbonate is like that. Then sodium chloride is Na plus Cl minus. So what does it become? Okay, double check against mine. CO2 H2O 2 2H Cl 1 2 3 like that. Supposed to be like that. Then if your equation, right, I see you have like 4 here, you have 4 here, 2 here, 2 here, right? And I don't get this. So if there is a multiple, you can reduce to simplest form. But answer is this. So metal oxides will react with acids to form salt and water only. So this reaction has a special name, it's called neutralization. So zinc oxide will react with sulfuric acid to form a salt and water. So you will fill this up. This contains the sulfate ion. So zinc sulfide, right? This sulfide is S2 minus, but sulfuric acid is sulfate, right? So it's like that. So shouldn't be zinc sulfide. Nope. So change that one. Yeah. Okay. Then now you can fill up, fill up, fill up, fill up. You can just type it out. I think it'll be easier. Okay. So the formula here is okay. Then the other side. Check this. So you don't have to put the bracket. Okay, then balance. Is it balance? Okay. Zinc here, zinc here. H2, O, H2, and O here. Then sulfate 1 here. Okay, so if we have not done, we will just revise this again. So we have metal hydroxides. They will react with acid to form salt and water only. Then the reaction is called neutralization, which is the same as metal oxide plus acid to give you salt and water. So now I have two reactants down here. So you will write the balanced chemical equation as a form of revision for test. So I'll give you some time. You write it, then we go through. Okay, time to balance. Are you trying to put this? Yeah. Okay. So this goes with this, H2 goes with H2, zinc goes with zinc. So you have the water is not balanced. Hydrogen and oxygen is not balanced. Done? Need help? No, not done. Okay, down here there are two hydrogens. Here this one has two hydrogen. Down here has two hydrogen. So total 4 hydrogen. Then this side has 1 oxygen. This side has 2 oxygen. So
4H here. Because got 4H on the left side.
So what should you do to the right hand side?
Put a 2 in front of it.
Yeah, that's right. So we have to talk about this. Just leave this alone first. Don't erase this. Okay. A salt, you have to define what is a salt because we are talking about salt plus water, salt plus hydrogen, salt plus carbon dioxide plus all those things, right? So what we know, we have to know what is a salt. So just now, when you have this zinc hydroxide and nitric acid, then you form zinc nitrate. So you form zinc nitrate here. So what happens is, like this. Okay, this hydrogen here has been replaced by the zinc ion. So when it replaced, right, the hydrogen ion has been replaced by the metal ion. So then whatever that is formed at the end, this thing is called a salt. So this is what it is. So the definition here just means a salt is a compound obtained by when the hydrogen of the acid is partly or completely replaced by a metal, in this case zinc ion or an ammonia ion. So this is what the salt means here. So earlier on, we see in our formulas, we have salt all over the place. This is what salt is. So I made a summary. So if you want, okay, so I made a summary down here. So if you want to revise or you want some reference, you can print this page out and then pin it somewhere. Okay, like that. So question 4A is yours. Now, now I do not tell you what the products are. So you have to figure out what products they are. So up in your sleeves, there are 1, 2, 3, 4 properties, 4 chemical properties, and whatever you have as outcome. Sorry, down here got typo. This is hydrogen. So first you have to figure out which chemical property is this. Okay. Then hydrogen gas. Hydrogen gas is diatomic. Next one. Need help? Lithium is in group 1. Lithium sulfate plus carbon dioxide plus water. Yeah. Check this and this. Group 1. Lithium is group 1. So it's plus only. So you have to go to sulfate and look at what formula sulfate has. Then you have to go to carbonate and look for carbonate's formula. Then is it balanced already? Yes, no, good no. Lithium, lithium. One carbon, one carbon. Then one sulfate, one sulfate. Then we are stuck to 3 oxygen, 3 oxygen. 2 hydrogen, 2 hydrogen. Balance already. Okay, perfectly fine. Okay, so there's another question. I think the teachers might have gone through it. You have to.
Like the spin if the hydrogen gas is there, the hydrogen gas will extinguish the lighter spin with a pop sound.
Yes. Carbon dioxide.
Carbon dioxide, I don't.
Haven't learned. Okay, carbon dioxide. What you do is you get something called lime water. So lime water is a colorless solution. Then, so let's say you have the reactant. Okay, then you have carbon dioxide. So what you do is you would pass it into lime water here. Sorry, bad drawing. Okay, lime water is calcium hydroxide. Then you bubble the gas through lime water. If carbon dioxide is there, right, is present, then a white precipitate will be formed. Meaning the colorless solution of lime water, you will see white stuff inside. Like that. So the explanation is use lime water. White precipitate is formed in lime water when carbon dioxide is bubbled into it. Which of the following statement is correct about the chemical reactions of dilute hydrochloric acid, nitric acid, and dilute sulfuric acid? I don't think it's A. A, copper does not react with acid. Does not react with dilute acid. Insoluble salt? Not always. They will react with alkalis, but not always insoluble. Yeah. So all acid molecules will split into hydrogen ions. Which salt is least likely to form by a reaction between a metal and a dilute acid? This is a bit difficult, but it's related to the previous question. Okay, because copper metal does not react with dilute acid. This one, which one will not react with dilute nitric acid to produce a salt. A, not D. D is a hydroxide, is a base or alkali. It's a base. Base will react with acids. So it will react with acid. So D isn't the answer. Nope, it's a base. Oxides are bases. Magnesium carbonate is a carbonate. Carbonates react with acid. This is also a base. It reacts with acid. So there's not only one answer down there. There's the odd one out. So answer is C. So I have uses of acid here. Some of the uses are here. So we look at the uses of sulfuric acid, hydrochloric acid, nitric acid. So sulfuric acids, they are all used for detergent, fertilizers, and car battery. Then ethanoic acid is used as a food preservative, flavoring agent. So just now we talk about hydrochloric acid. Hydrochloric acid is found in your stomach juices. It's used to digest food. Then nitric acid, if I'm not wrong, they are also in the use of fertilizers. I used to make fertilizers. You can read up on this. Which part did you miss? So I'm at the reaction between the hydrogen ion and the hydroxide ion. So the two of them, they react with each other to form water. Then this process is called neutralization. So base and alkalis will react with acid, you get salt and water. So the ionic equation, this one is the ionic equation for neutralization. So they will always ask for what is the ionic equation for neutralization. It is always this answer. So at the end of the reaction, you will form a solution which is neutral. That's why it's called neutralization. So because that reaction is the ionic equation for neutralization is always that equation. That means the answer is always the same. So answer is this one.
What is a neutralization reaction?
Yeah. So which one is a neutralization reaction?
What is a neutralization reaction?
What is a neutralization reaction?
Yeah.
Okay, so let's go back then. Okay, so this is the section on neutralization. So it means that you have an acid or a base and an alkali, then two of them will react. After the reaction, you'll get salt and water. Then, of course, this in ion form, right? That would mean that the acids they produce H plus ions, and this alkali stuff will produce OH ions. So the SH plus ions from the acid will react with the OH minus that comes from the alkali or the base. Then the two of them combine and give you water. So these two chemicals, they react with each other, you get water, and your end result is that a neutral solution will be formed. That means whatever you have at the end will be neutral. Meaning that if you take a universal indicator and you test it, you will get pH 7. So neutralization means a reaction where you have acid and alkali together, and eventually you get salt and water, and the overall solution is neutral. Okay?
Yeah.
So
is it there's more than one? Is it there's more than one indicator, or there's only one indicator?
Yes, there's more than one indicator. So
then why that's
did I have the indicator here? Nah, so I've gone back to this one. This one is about indicator. You have the pH scale. Then the universal indicator is the one that change color all the time. So every pH will change color. So you have a variety of colors. That's one indicator. Then there are other indicators like methyl orange, phenolphthalein, screen methyl orange, litmus, bromothymine blue. All of them will change color at a certain pH range. So that means methyl orange will be red in acidic and then yellow will be when it's alkaline. So other indicators, they will have other colors and they change color differently. Like what is indicated in this slide? Question?
That means in one indicator, one solution of the pH, that 2 is one higher, then in another indicator, it's another higher.
Yes. So that means pH 2 in methyl orange will be red, but pH 2 in phenolphthalein will be colorless. So it will be purple if it's in screen methyl orange, and it's red in litmus, and it's gonna be yellow in bromothymine blue.
I thought litmus paper only have red and blue.
Litmus is only red and blue, yeah, litmus.
Then I thought indicators have red, green, blue, indigo, violet.
That is universal indicator, which is this one. This is the universal indicator. So it will be red in 0 to 4, then it become orange in at 5, yellow at 6, green at 7, then bluish green at 8, blue at 9, bluish purple at 10, and then purple at the other end. So indigo is a shade of purple. So this is the one that changes color all the time. There'll be red. Red when it's strong acid. Then you'll be indigo, violet, whatever you call it, purple, any shade of purple. Then you'll be alkaline. Then it will be green color when it's neutral. That is universal indicator. Then the other indicator you probably have is litmus. And you may also have either methyl orange or phenolphthalein. But there are many, 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 many indicators, which will then come up, which will bring you to this kind of question where they say you have two indicators, and then what color will they show at a specific pH? You see? Question? So neutralization means you have acid base, they react, and then you get a neutral solution. Which equation best represents the reaction between an acid and an alkali? Yeah. First, that comes from no matter what, right? Whichever reaction, whichever neutralization reaction, whatever chemicals you use, neutralization is always H plus OH gives you water. So A is the answer as what you do. Okay. This is another one. You will notice not all the state symbols are there because the AQ that is written down there just means that it's dissolved in water in solution. Then concentrated sulfuric acid means it's very high in sulfuric acid. Then C, right? There's an AQ in ammonium hydroxide. That one is just to indicate equals ammonia. Okay, let's see if the answer is correct. Okay. Yep. So are you familiar with this controlling pH of soils? So they have this story where, okay, in certain questions, in certain test questions, they will always ask you about pH of soils, farming, growing crops, growing plants, that kind of thing. So what they are trying to tell you is different, okay, how the plants grow, how your crops grow is affected by the pH of soil. So certain plants, they will grow well in certain conditions. So not all will grow in the same condition. So most of the plants, they'll grow well around pH like this, where it's neutral, the soil is neutral or slightly acidic. Then some plants will grow better when the soil is weakly alkaline or more acidic, depend on what plant you have. So what happens is we can only have a piece of land to grow, as in farmers only have the piece of land that they have, to grow whatever crops they want to grow. So it is not possible to have different patches of soil to grow different plants. So in order to grow the different kind of crops or different kind of plants on the soil on the same piece of land, they would have to control the pH of the soil using certain methods. So in this case, right, chemicals will be added to adjust the pH of the soil. So if the soil is too acidic, bases will be added. So you have calcium oxide, calcium hydroxide will be added. So what these do is they will raise the pH of the soil. But of course, you must add with caution because adding too much base will make the soil too alkaline and unsuitable for plant growth. Then that's the story. So the question they will ask you is something like this. Which of the following substance is used to reduce the acidity in soil? Okay, that's right. Okay, so this is another variation. Like instead of using soil, land, and all that, they ask you about a lake that's polluted with acid rain. Marble chips are okay. Marble chips are calcium carbonates. Then this also in some sense is calcium carbonate. So C and D both are calcium carbonate. One is powdered and one is not powdered. One comes in big pieces. Then A aqueous ammonia is a so you have 4 options there. Okay. Okay, what happens in A and B? Okay, A and B should not be added. One is because they are soluble in water. It is very possible that you add too much of this into your lake. Then when you add too much into the lake will become alkaline. So when that happens, other pollution, other environmental issues will happen. Whereas C and D, powdered chalk and marble chips, they're all calcium carbonate. They are insoluble in water. So they are insoluble in water. So when they're what happens when they're insoluble in water is like this. If there's nothing in the lake that will react with the carbonate, the calcium carbonate will just remain as it is, making it easy for you to remove the powdered chalk or the marble chips. So then you can just remove it. It only reacts with the acid. Then you use the powdered one instead of the marble chips, right? Powdered one you can sprinkle less and it's easier to control the amount of sprinkling. And if it is not reacting with the lake, then you can just scoop it out, like filter the water or remove from the surface of the water very easily. So that's why answer is C. Marble chips they are bigger in piece and you have to add more. Then you have more to clear. Then it's more polluting. Okay, property of bases. Okay, so bases will react with acid to give you salt and water. This one shouldn't be any issue. Then it reacts with metal hydroxide. It reacts with some salt to form a metal hydroxide and a salt and another salt. So what happened is like this sodium hydroxide here. Sodium will take the sulfate and the iron will take the hydroxide, and eventually we'll get sodium sulfate and iron to hydroxide. So this is the salt. and this is the metal hydroxide. So we will need you to practice your balancing equation here. So I'll leave the rest for you to continue. Check this. Check this. Check the chemical formula. Done. Okay, iron 2 sulfate means that the valency of iron is 2 plus. Sulfate is SO4. What's the valency? What is the valency of sulfate?
minus
Sorry?
2 minus.
Yeah, so then these two will exchange and you get Fe2SO4 bracket 2, right? Then what you can do is you can reduce to simplest form. That means this one,
SO4.
then you become like that.
Bracket SO4.
Fe don't need the bracket already, just like that. So this is FeSO4. Then, yeah, this one is correct. Then you can start balancing. So this 2 is correct, the formula. So you put a 2 here. SO4, SO4. Then, so you have 2 here. So this one must have a 2 here. Oh, wait. No. I look at the wrong one. This is here, here. Then after that, then you have 2 oxygen and 2 hydrogen. 2 oxygen and 2 hydrogen here. Yeah. So in the end, it will be as what you have written. ESO4 is Fe hydroxide 2 plus Na2SO4. Like that, this is the answer. So our bases will react with ammonium salts to form ammonia gas and water and another salt here. So then calcium hydroxide plus ammonium chloride will give you ammonia gas plus water plus the salt, this one, calcium chloride. So now your job is to continue from where I stopped. Okay, is it balanced? If you have a 4 here, that means you must have 4 nitrogen. So NH4Cl means there's only 1 nitrogen here. So because of that, right, I don't have to check the rest, and I'll know it's not exactly correct anymore because the number of nitrogens is unequal. So then I'll start with all the more uncommon elements. That means not oxygen and not hydrogen. Okay, so there's Cl2 down here. So I'll put a 2 down here to try. So that will balance the number of chlorine. Then there's 1 calcium here, 1 calcium here. Then this one means there's 2 oxygen and 2 hydrogen. So since I have 2 nitrogen here, I will try and put a 2 down here. So that will balance the nitrogen. Right? Then, so what I am left with is this one, 3 hydrogen here, and 2 hydrogen here. So there is Okay, 3 here. Then there's a 2 outside here. That means there's 6 hydrogen here. And there's 2 hydrogen here. And there's 1 oxygen here. But clearly I have 2 oxygen here. So I need to put 2 here to balance the oxygen. So it becomes
The
4 and
hydrogen will also become 4.
which one becomes 4?
Hydrogen will also become 4.
Which hydrogen here?
The
So here,
water, the water.
yeah, this one.
Yeah.
So now, so there will be 10 hydrogen in total on the right hand side. So then you count on the left hand side, there's 2 hydrogen here and 8 hydrogen here. So total also 10. Then that means it's balanced already.
Balance means the number of NH must equal to the number of NH.
N is one thing, H is one thing.
Equals to the number of OH.
That means it's actually just number of Ca on the left must be equal to number of Ca on the right. Number of N on the left must be equal to number of N on the right. Number of O on the left must be equal to number of O on the right. H also the same. So that's balancing equation. Okay, so here missing one thing. Okay, so you have a summary, you can print out and then you can keep it. Okay, so what is the salt? Same. Two oxygen, 2 oxygen. Yep. Same question as just now. Describe a test to confirm the presence of ammonia gas in the reaction between an ammonium salt and an alkali. Test for ammonia. White precipitate is not a test for ammonia. White precipitate is the lime water test for carbon dioxide. Lighted spleen is the test for hydrogen, and glowing spleen is the test for oxygen. So now is the test for ammonia.
The only teach the lighted spin and the white precipitate.
Okay, then I'll tell you, and then you just keep that in mind. There's the damp red litmus paper test. So you just put at the mouth of the test tube, the damp litmus paper will turn blue. So there are several uses of bases and alkalis. You can just take note. So the ammonium solution, they are used for window cleaners, and then they are also used in fertilizers. Calcium oxide is the one you see with the acidic soil. So what you do is you neutralize acidic soil and you make iron, you make concrete with calcium oxide. Then magnesium hydroxide is found in toothpaste and the pills for indigestion. Then sodium hydroxide is the one that you use to make soap and cleaning detergents. So this one is just roughly read through, you remember some uses. If they ask you, just give them one of them. So this is our last section, just to talk about acidic, basic, amphoteric, and neutral oxides. A compound named the oxide, that means it's actually a compound made out of an element and oxygen. So if I have sodium react with oxygen, I'll get sodium oxide. Then if I have carbon reacting with oxygen, I'll get carbon dioxide. I can also get carbon monoxide. So the whole point is just an element plus oxygen means it's a compound of, it's an oxide. So there are 4 types of oxides, which is basically the acidic oxide, basic oxide, amphoteric oxide, and neutral oxide. So according to the chart, you will see first elements are classified into metal and non-metal. So the metals will form basic oxides and amphoteric oxides. Then the non-metals will form acidic oxide and neutral oxides. This one is quite important to know. So then you have to go on and know the different characteristics of different oxides. So you know that non-metals may form acidic oxides. So these acidic oxides are usually gases at room temperature, and they will dissolve in water to form acidic solution. So for example, carbon dioxide reacts with water to form carbonic acid. So you will have an acid in the end. Acidic oxides, they will react with alkalis to form salt and water. So then becomes a bunch of equations again. So carbon dioxide plus sodium hydroxide will give you sodium carbonate and water. So this is just to tell you that acidic oxides, they react with bases and alkalis. So you have other acidic oxides, which is sulfur dioxide, sulfur trioxide, phosphoric 5 oxide. They are all non-metal oxides. Then you can have basic oxides. So metal oxides are called, metal oxides usually are basic oxides. So these basic oxides, they are solids at room temperature, and most of them are insoluble in water. So you can name sodium oxide, you can name potassium oxide, you can name calcium oxide. All these are all basic oxides. A few of them will, namely sodium oxide, potassium oxide, and calcium oxide, they will dissolve in water to form alkaline solutions. So you have an example here. They say calcium oxide plus water gives you calcium hydroxide. Basic oxide is the reverse of acidic oxide. So basic oxides, they react with acid to form salt and water. Acidic oxide, they react with bases to form salt and water. So then you have the chemical equation here. Calcium oxide plus hydrochloric acid give you calcium chloride and water. They might expect you to write this. Then the third type, which is the amphoteric oxides. Amphoteric oxides are also metal oxides. That they are a bit special because they react with both acid and bases to form salt and water. So for example, zinc oxide react with acid, we get zinc chloride and water here. Then it reacts with base to form salt and water again over here. Amphoteric oxides are easier to remember. So they are aluminum, lead, and zinc oxide. These 3 are the only amphoteric oxides that you need to know. Then you have the last type, which is the neutral oxides. So some non-metal oxides, they form oxides that show neither basic nor acidic property. That means they don't react with acid and they don't react with base. Then they are insoluble in water. And one characteristic to know is in a molecule of neutral oxides, there is always, almost all the time, only one oxygen. So you can have water, you can have carbon monoxide, you can have nitric oxide. All these are all neutral oxides. So they don't react with base, they don't react with acids. So the summary is here. And again, you can print it out for your own purpose, reference, etc. Now, this is a chart to show you how to determine the nature of the unknown oxide. That means to say you want to know whether the oxide you have on your hand is neutral, basic, amphoteric, or acidic. So what you first do is you take the oxide and then check if it's soluble in acid. If it's soluble in acid, that means it is actually a basic oxide or amphoteric oxide. If it's not, then it will become an acidic oxide or a neutral oxide, because acidic and neutral oxides don't react with acids. So once you get that, you will then decide whether it is soluble in alkalines, alkalis or not. So you come from this point here first. If it's soluble in alkalines and alkalis, that means it's an amphoteric oxide. If it's not, then it's a basic oxide. So same goes on the other side. If it is soluble in alkalis, then it's an acidic oxide. If not, it's totally neutral. This chart is a chart for reference only, because they won't ask you to regurgitate this chart. Instead, they will ask you to apply the information from here. Question 14. Which of the following can react with both acids and alkalis? That means it means they are looking for amphoteric oxide. So they're asking you which of these 4 options is an amphoteric oxide. So recall which oxides are amphoteric oxides. We can go back to this. You see amphoteric oxides. There are 3 of them down there: lead, aluminium, and zinc oxide. So then you go to here, pick your amphoteric oxide. Yes, like that. So the other 2 amphoteric oxides are zinc oxide and aluminium oxide. Okay, 15. Which of the following oxides causes the pH value of soils to drop below 7? So what kind of oxides are they looking for? Carbon monoxide is a neutral oxide, 1 oxygen only. So it's neutral. If it's neutral, it does not react with water to form acids. So A is not the answer. So acidic oxides are non-metal oxides. So you have to go to your options, pick the non-metal oxide. Yeah, that's the answer. We will let you fill in. Nitrogen dioxide has more than 1 oxygen. So it cannot be a neutral oxide. It must be acidic. So now we have another set of questions. You have to deduce whether they are, you have to deduce what kind of oxides are these 4 oxides based on the characteristics given by the question. Why is it an acidic oxide? What evidence show that it is an acidic oxide? If I were to ask you for an explanation, why is it an acidic oxide? Would you be able to produce the answer? You don't know. Yeah, it first is it reacts with water. Okay, so the first evidence it reacts with water, and then when it reacts with water, it turns blue litmus paper red. This one tells you that the solution form is acidic solution. So A, crystalline solid that is able to react with water to produce an acidic solution must be an acidic oxide. It's because it reacts with water to produce a solution that's acidic. So that's why A is an acidic oxide. Part B. So you have another oxide. Okay, why is it an amphoteric oxide?
Because it forms a higher solution when it is mixed with acid.
And also sodium hydroxide.
And base.
Yeah, so the answer would be because it reacts with sodium hydroxide and hydrochloric acid. So it must be an amphoteric oxide. Correct. Next. Okay, correct. Because it has no reaction with both. Last one. Okay.